Professor Richard Harrington believed intelligence had a certain look. In his mind, it wore tailored suits, carried Ivy League credentials, and stood confidently behind polished podiums beneath the warm lights of prestigious lecture halls. What he never imagined was that one quiet woman in a faded gray cardigan would soon challenge everything he thought he knew about genius. The Mathematics Symposium at Westbridge University had drawn some of the brightest academic minds from across the country. Sunlight filtered through tall glass windows and spilled across the polished oak floor, reflecting softly off rows of notebooks, tablets, and silver coffee thermoses. Nearly 200 students, researchers, and professors filled the hall, their attention fixed on the stage, where Professor Harrington stood with the calm authority of a man used to admiration. At 52, Harrington was more than a respected professor. He was a mathematical celebrity in academic circles, known for elegant theories and a sharp tongue that left little patience for questions he considered beneath him. His newest lecture that afternoon revolved around a complex theoretical proof that had already sparked debate among top scholars. As he wrote a final equation across the massive chalkboard, the room remained silent except for the soft scratch of chalk. And that, Harrington said confidently, dusting his hands together, is why the structure holds under every known condition. A few students nodded, others typed notes quickly, eager to capture every word. But in the far corner of the lecture hall, unnoticed by most of the audience, stood Emily Carter. Emily had finished emptying a recycling bin near the back row and now paused beside her cleaning cart. At 34, she moved quietly through the university halls every day, pushing carts, wiping desks, and collecting discarded coffee cups left behind after long study sessions. Most students barely noticed her. Some assumed she was just another maintenance worker passing through. Yet Emily lingered at the edge of the room longer than necessary, her eyes fixed on the chalkboard. Numbers and symbols flowed across it like a language she knew by heart. Harrington continued explaining the final steps of his proof when Emily's brow tightened slightly. Something about the equation bothered her. Not a large mistake, just a subtle gap in the logic, a small detail most people might never see. She hesitated, glancing around the massive lecture hall filled with brilliant minds and polished reputations. People like her didn't interrupt professors. People like her didn't question world-famous mathematicians. But the thought wouldn't leave her. After a quiet moment, Emily lifted her hand slightly. It was such a small gesture that at first no one noticed. Then one student turned, confused. Another whispered. Professor Harrington paused mid-sentence, his eyes slowly scanning the room until they landed on the woman beside the janitor card in the back. For a brief second, he looked puzzled, as if trying to place why she was even there. Yes, he said finally, his voice carrying through the hall with mild impatience. Emily spoke carefully. I might be misunderstanding something, but shouldn't the third transformation fail if the variable approaches negative infinity? The room froze. Pens stopped moving. A few students exchanged looks. Professor Harrington blinked once, clearly not expecting a question from someone standing beside a mop bucket. Then a slow smile crept across his face, the kind professors sometimes wear when they believe a moment of public embarrassment is about to unfold. And in that moment, Professor Harrington made a decision he would soon regret. Professor Harrington's smile lingered for a moment as he leaned slightly against the podium, studying the woman standing beside the janitor cart in the back of the lecture hall. The room had grown strangely quiet, the kind of silence that settles when people are unsure whether they just witnessed something awkward or something interesting. Harrington adjusted the cuff of his tailored jacket and spoke with a tone that carried equal parts amusement and authority. You believe there is a problem with the transformation? He asked. A few students near the front row turned in their seats to get a better look at the woman who had spoken. Emily Carter stood calmly, her hands loosely resting on the handle of the cleaning cart. Her cardigan looked worn from years of use, and a faint dusting of chalk powder still lingered on the sleeves from wiping boards earlier that morning. She did not appear nervous, but she also did not appear eager for attention. She simply nodded once. I might be mistaken, Emily said carefully, her voice steady but quiet enough that the microphone above the podium had to carry Harrington's response instead. But if the variable moves toward negative infinity, the third step would collapse the structure of the proof. A few murmurs passed through the room. Most students did not fully follow the technical detail, but they understood enough to realize she had pointed at something very specific. Professor Harrington let out a short laugh, the kind that professors sometimes use to dismiss an interruption without appearing openly rude. "Mathematics can certainly look confusing from the outside," he replied, pacing slowly across the stage as if addressing the entire hall rather than Emily herself. "But this proof has already been reviewed by several top departments." A ripple of light chuckles moved through the audience. Emily remained still. Harrington stopped near the chalkboard and picked up a piece of white chalk, tapping it lightly against the board. "However," he continued with a theatrical pause, "since you have taken such an interest in the discussion," his eyes returned to Emily, and the smile widened slightly. "Perhaps you would like to demonstrate your thinking." The room shifted instantly with anticipation. Some students leaned forward in their seats, while others exchanged curious glances. Harrington turned back to the board and began writing quickly, the chalk sliding across the surface in confident strokes. Symbols, limits, and complex expressions filled an empty corner of the board in less than 30 seconds. When he stepped aside, the equation looked dense and intimidating, the type of problem that graduate students might spend hours debating. Harrington placed the chalk down and gestured toward the stage with an open palm. "If the transformation fails," he said smoothly, "then I imagine you can show us where." A few students laughed quietly again. The invitation was not truly an invitation. It was a challenge, the kind designed to make the outcome obvious before it even began. Emily hesitated for a moment, glancing at the crowded lecture hall. Nearly 200 eyes now rested on her. Professors in expensive suits, doctoral candidates with open laptops, visiting scholars from across the country. None of them expected anything remarkable from the quiet woman standing beside a cleaning cart. But after a brief pause, Emily stepped away from the cart and began walking toward the front of the room. Her footsteps were soft against the polished oak floor, yet in the silence they seemed to echo. Harrington watched with folded arms, clearly confident that the moment would resolve exactly as he expected. What he did not realize was that the quietest mind in the room had just accepted his challenge. Emily Carter walked steadily down the center aisle of the lecture hall, while nearly 200 pairs of eyes followed her every step. The soft wheels of the cleaning cart remained behind in the corner where she had left it, a quiet reminder of the role everyone in the room believed defined her. The distance from the back wall to the stage was barely 40 feet, yet in that moment it felt much longer, as if the entire room had stretched into a corridor of judgment and curiosity. Some students leaned toward one another whispering quietly. A few smiled with the expectation that this would become a harmless academic joke. The moment a maintenance worker realized she had stepped far outside her depth. Professor Richard Harrington stood beside the chalkboard with his arms folded, watching with the calm confidence of a man who had spent decades proving people wrong. He had delivered lectures at Princeton, Stanford, and the Massachusetts Institute of Technology. He had debated mathematicians whose textbooks filled the backpacks of half the students sitting in this room. To him, the outcome of this moment felt obvious. Emily stepped onto the low stage and paused near the massive chalkboard filled with symbols and transformations. Up close, the equation Harrington had written looked even more complex, a dense chain of expressions layered with limits and substitutions designed to test advanced graduate students. The white chalk rested on the wooden tray beneath the board. For a moment, Emily simply studied the equation without touching it. The silence in the room deepened. A student near the front row checked the time on his laptop screen. Another crossed her arms, waiting for the inevitable awkward pause that would send Emily quietly back to her cart. Harrington cleared his throat with polite patience. "Take your time," he said, his voice carrying lightly through the hall. A faint ripple of amusement moved through the audience. Emily finally reached down and picked up the chalk. The small piece of white stone rested easily between her fingers, as though she had held it 1,000 times before. She looked at the equation again, her eyes moving across each symbol with careful attention. Then she began to write. The first line appeared beneath Harrington's equation with calm precision. Instead of attempting to solve the entire structure immediately, Emily rewrote one portion of the transformation in a slightly different form. The motion of her hand was smooth and unhurried. Several students frowned as they followed the change. One graduate student in the third row leaned closer to the board, suddenly more interested. Emily continued, adding another step, then another. Each line flowed logically from the last, simplifying part of the expression while isolating the variable that Harrington had mentioned earlier. The soft scratching sound of chalk against the board echoed clearly through the quiet hall. Within less than a minute, the light laughter that had filled the room earlier had disappeared completely. Harrington's posture shifted slightly. His folded arms loosened as he watched the new steps forming beneath his own work. Emily paused for a brief moment and stepped half a step to the side, studying the lines she had written. Then she added another transformation that redirected the entire chain of logic. A quiet murmur moved through a cluster of graduate students near the center of the hall. One of them whispered, "Wait a second." Emily continued writing with the same calm focus, as if the audience no longer existed. Another line appeared, and then another, and suddenly the direction of the equation began to change in a way that several mathematicians in the room recognized instantly. A visiting scholar seated near the aisle slowly lifted his head, staring at the board with growing concentration. Professor Harrington no longer looked amused. He watched the chalk moving across the board and felt an unfamiliar hesitation settle into the room. Something about the structure unfolding in front of him did not look like the mistake he had expected to see. Emily Carter continued writing with steady focus, while the lecture hall grew quieter with every line that appeared beneath the original equation. The chalk moved smoothly across the board, forming a chain of transformations that began reshaping the problem Professor Harrington had presented. At first glance, her steps looked simple, almost modest, but anyone in the room with strong mathematical training could see that something unusual was happening. Instead of forcing the equation through the complicated path Harrington had designed, Emily had redirected the logic entirely, isolating a structural weakness that had been hidden inside the third transformation. A graduate student near the center row leaned forward so quickly that his chair legs scraped softly against the floor. Another student stopped typing notes and stared at the board with narrowed eyes. The room, that had once held quiet laughter, now held something very different. Curiosity. Emily paused briefly, studying the lines she had written. Then she added another step that simplified the expression even further, reducing several dense components into a single elegant term. The transformation was so clean that a few professors in the audience exchanged surprised glances. Professor Harrington watched from only a few feet away. At first he had expected Emily to stall or hesitate, perhaps write something uncertain before stepping away from the board. But she had not hesitated once. Each movement of the chalk seemed deliberate, confident, and strangely efficient. Harrington slowly unfolded his arms and took one step closer to the board. His eyes moved across the developing proof with growing attention. Emily added another line, adjusting the limit structure that Harrington had built earlier in his lecture. That small change revealed the flaw she had mentioned from the back of the room. The third transformation did not collapse immediately, but under the conditions she had described, the entire chain lost its stability. A quiet voice from the audience whispered, "That is exactly what she said." Emily did not react to the whisper. She simply continued writing, her hand moving calmly as the chalk traced another logical step. Now the equation had reached a point where the structure of the proof could move in two possible directions. One direction preserved Harrington's original argument, but required a delicate assumption that had never been clearly stated. The other direction simplified the system entirely and led toward a much stronger conclusion. Emily chose the second path. The next line she wrote caused a visible reaction from several mathematicians sitting near the aisle. One of them leaned toward his colleague and murmured something that sounded like disbelief. The chalk paused again. Emily stepped slightly to the side and looked at the board as if reviewing the path she had just built. Then she wrote one final transformation that connected the entire structure together. When she finished, the equation on the board looked dramatically different from the one Harrington had written only minutes earlier. It was cleaner, stronger, more complete. The soft scratching sound of chalk stopped. Emily lowered her hand and placed the chalk gently back onto the tray beneath the board. For a moment she said nothing. No one else spoke either. Nearly 200 people stared at the proof, stretching across the board while the meaning of it slowly settled into the room. Professor Harrington remained perfectly still. His eyes moved carefully from the first line Emily had written to the final step that completed the transformation. The confident smile he had worn earlier had completely disappeared. A visiting mathematician seated in the fourth row slowly stood up, still staring at the board as if he needed to see the equations from a different angle. The lecture hall remained silent as the realization began spreading from one mind to the next. Emily Carter had not struggled with the problem. She had rebuilt it. The silence inside the lecture hall stretched longer than anyone expected. Nearly 200 students, professors, and visiting scholars stared at the chalkboard where Emily Carter's solution now covered nearly half the surface. The structure was unmistakably clear. The transformation she had introduced earlier had exposed the weakness in the original proof, and the final steps she added had rebuilt the entire argument into something stronger, more stable, and surprisingly elegant. For a moment, no one moved. The only sound came from the quiet hum of the overhead lights and the distant ticking of the large clock mounted above the rear exit. Professor Richard Harrington stood only a few feet away from the board, his eyes moving slowly across each line Emily had written. The confident rhythm of the lecture he had controlled just minutes earlier was gone. Instead, he studied the equations with the careful attention of someone trying to understand something unexpected. In the fourth row, the visiting mathematician who had stood earlier took a slow step closer to the stage. His name was Dr. Michael Bennett, a researcher from a major institute known for his work in advanced mathematical structures. He leaned slightly to the side, reading the transformation Emily had introduced in the middle of the proof. His expression shifted from curiosity to genuine astonishment. "This changes the entire stability argument," he said quietly, though his voice carried easily through the silent room. Several heads turned toward him. Bennett continued studying the board, tracing one step with his finger from a distance, as if confirming the logic. "She did not just correct the condition," he added. "She removed the instability completely." A wave of murmurs spread through the audience as more people began recognizing the implication of what they were seeing. "Graduate," students whispered to one another while flipping through notes from earlier in the lecture. A professor near the aisle leaned forward in his seat, staring intensely at the final line Emily had written. Professor Harrington finally spoke, though his voice sounded noticeably more measured than before. "That transformation assumes a structural shift in the variable domain," he said slowly, directing the observation toward the board rather than directly at Emily. Emily turned slightly, her calm expression unchanged. "Yes," she replied gently. "But the shift already exists if the variable approaches negative infinity, which is what the earlier condition allows." The room grew quiet again. Harrington looked back at the third step in his original chain of equations. For a moment he said nothing. Then he stepped closer to the board and studied Emily's earlier correction more carefully. The logic was difficult to deny. Several mathematicians in the audience had already reached the same conclusion. The flaw Emily had noticed was subtle, but once revealed it could not be ignored. Bennett exhaled softly and looked toward Emily with open admiration. "That is an elegant reconstruction," he said. "Most people would have spent weeks debating that correction." Emily did not appear interested in the attention. She simply stepped back from the board, giving the audience a clear view of the completed proof. The chalk dust rested lightly on her fingertips as she folded her hands together. Across the lecture hall the reaction was spreading. What had begun as quiet amusement had transformed into something far more serious. The audience was no longer watching a curious interruption. They were witnessing something extraordinary. Professor Harrington remained near the board, his eyes moving slowly across the final transformation. The equation he had written earlier was still visible above Emily's work, but now it looked incomplete, almost unfinished beside the cleaner structure she had built beneath it. For the first time since the lecture began, Harrington appeared genuinely uncertain about what to say next. The lecture hall remained frozen in a silence that felt almost unreal. Students who had arrived expecting an ordinary academic presentation now found themselves staring at the chalkboard as if they were witnessing a moment that would be discussed for years. Emily Carter stood a few steps away from the board with her hands loosely folded, the faint dust of chalk still visible on her fingers. She did not look proud or nervous. She simply looked calm, as if solving the equation had been the most natural thing in the world. Dr. Michael Bennett continued studying the proof with growing fascination. He moved a little closer to the stage, his eyes tracing the structure Emily had built beneath Professor Harrington's original argument. "Look at this transition," he said quietly to a colleague seated nearby. She eliminated the unstable condition completely. The proof becomes stronger instead of weaker. The colleague leaned forward, following Bennett's gaze. Within seconds, several more professors began murmuring to one another. The realization was spreading through the room like a slow wave. What Emily had written was not simply correct. It was elegant in a way that mathematicians deeply respected. Professor Harrington remained near the board, studying the steps again and again. The confident posture he had carried earlier was gone, replaced by careful concentration. He lifted a piece of chalk from the tray and pointed at the third transformation in Emily's reconstruction. "This step," he said slowly. "You replaced the limit structure entirely." Emily nodded once. "Yes," she answered calmly. "The original limit assumes stability across the full range, but if the variable approaches negative infinity, the structure already breaks. Shifting the domain removes that instability." Harrington stared at the equation for several seconds. The logic was undeniable. Anyone trained in advanced mathematics could see it now that the path had been revealed. What made it remarkable was not simply the correction itself, but the clarity of the solution. Emily had not struggled through dozens of steps. She had moved directly to the structural weakness and rebuilt the proof with quiet precision. In the audience, a graduate student whispered to his friend, "How did she see that so fast?" Another student shook his head slowly. "I do not even understand half of what she wrote." Dr. Bennett finally turned away from the board and looked directly at Emily. His expression carried genuine curiosity now. "May I ask where you studied?" he said. The question hung in the air. Nearly everyone in the hall turned toward Emily, suddenly realizing how little they knew about the quiet woman who had walked up from the back of the room. Emily hesitated for only a moment before answering. "I did not study here," she said gently. "I mostly learned on my own." A few students blinked in surprise. Bennett tilted his head slightly, as if trying to understand what she meant. "On your own," he repeated. Emily nodded. "I read textbooks after work sometimes," she said simply. The statement sounded almost casual, yet it landed in the room with unexpected weight. Professor Harrington slowly lowered the chalk back to the tray. He looked at the completed proof again, then at Emily. The contrast between expectation and reality had become impossible to ignore. Just minutes earlier, he had invited her to the board expecting an awkward mistake that would reinforce his authority in front of the room. Instead, the quiet woman standing beside him had rewritten the most important equation of his lecture. And the realization of what that meant was only beginning to settle across the entire hall. The lecture hall no longer felt like a classroom. It felt like the moment after something impossible had just happened, when every person present was trying to adjust their understanding of reality. Emily Carter stood quietly near the chalkboard while the equations she had written continued to draw the attention of every mathematician in the room. The proof stretched across the board in clear white lines, each transformation precise and purposeful. Students who had been whispering earlier now sat completely still, studying the work with growing respect. Dr. Michael Bennett remained near the front row, his arms loosely folded as he examined the structure once more. He had spent more than 20 years studying complex mathematical systems, and rarely did he encounter a solution that felt both unexpected and undeniably elegant. After another long moment, he looked toward Emily again. "You said you mostly studied on your own," Bennett said carefully, his tone filled with genuine curiosity rather than skepticism. "That level of structural reasoning usually takes years of advanced training." Emily gave a small, thoughtful shrug. "I had time," she replied softly. A few students exchanged puzzled glances. Bennett smiled slightly, but his eyes remained thoughtful. "Most people with time do not rebuild theoretical proofs during a lecture," he said. A quiet ripple of laughter moved through the room, though this time the laughter carried admiration rather than mockery. Professor Richard Harrington stood beside the board, still studying the reconstruction Emily had written beneath his original equation. His reputation had been built on intellectual precision, and the truth now standing in front of him demanded acknowledgement. Slowly he turned toward the audience. "For those of you trying to follow what just happened," he said with measured calm, "Miss Carter identified a structural instability in the third transformation of my proof." He gestured toward the board with an open hand. "Her reconstruction removes that instability entirely." A murmur of agreement spread through several professors seated near the front rows. Harrington continued speaking, though his voice carried a tone that was far more thoughtful than the confident lecture he had delivered earlier. More importantly, he added, the alternative path she introduced simplifies the argument significantly. Emily shifted her weight slightly, as if uncomfortable with the attention now focused entirely on her. She glanced toward the back of the hall, where her cleaning cart still waited quietly beside the wall. To most people in the room, it had been invisible earlier. Now it stood like a silent reminder of the assumption everyone had made when they first saw her. Dr. Bennett noticed the glance and smiled faintly. You know, he said, addressing Emily again, most mathematicians would be proud to present a correction like that at a conference. Emily looked slightly surprised by the comment. I was only answering the question, she replied. Several students near the middle rows shook their heads in disbelief. One of them whispered to a friend, she fixed the whole proof, and she says she was only answering the question. Harrington heard the whisper, but did not react. Instead, he turned back to the board one more time, studying the final transformation Emily had written. For a brief moment, he remained silent. Then he stepped aside from the board completely, clearing the view for the audience. Well, he said slowly, his voice echoing through the quiet hall. It appears that today's most important contribution did not come from the podium. The room fell silent again, not out of tension this time, but out of recognition. The quiet woman who had entered the lecture hall pushing a cleaning cart had just reshaped the most difficult equation of the afternoon, and the realization of who she might truly be was only beginning to unfold. For several long seconds the lecture hall remained perfectly still, as if no one wanted to be the first person to break the moment. The proof on the board had already said everything that needed to be said. Emily Carter stood quietly near the edge of the stage, her posture relaxed, her expression calm, while nearly 200 people continued staring at the work she had written. The equations stretched across the chalkboard in crisp white lines, transforming what had started as a complicated theoretical argument into something clearer and far more stable. Professor Richard Harrington slowly stepped away from the board, giving the audience a full view of the reconstruction. The confidence that had defined his lecture earlier had softened into thoughtful respect. He glanced once more at the final transformation and nodded almost to himself, acknowledging the precision of the solution. Dr. Michael Bennett broke the silence first. He turned toward the audience with the excitement of someone who had just witnessed a rare intellectual moment. For those of you studying advanced theory, he said, his voice carrying easily through the hall, what you are looking at is not simply a correction. It is a stronger framework than the original proof. A quiet wave of murmurs passed through the rows of students. Some of them had already begun taking pictures of the board with their phones. Others hurried to copy the final steps into their notebooks, aware that they were watching something extraordinary unfold in real time. Bennett looked back at Emily with a warm smile. Miss Carter, do you realize that what you wrote could easily become the basis for a published paper? Emily blinked slightly, clearly not expecting the suggestion. I was only trying to explain the instability, she replied gently. Bennett laughed softly, not in disbelief, but in admiration. That explanation would take most mathematicians weeks to construct, he said. Near the center of the hall, a group of graduate students had begun quietly debating the logic of the transformation. One pointed toward the middle of the board where Emily had shifted the domain condition. That step changes everything, he whispered. Another nodded slowly. It removes the entire contradiction. The realization continued spreading through the audience like a growing light. What had started as a small question from the back of the room had now become the highlight of the entire symposium. Professor Harrington finally turned toward Emily directly. His expression was serious but respectful. Miss Carter, he said carefully, may I ask how long you have been studying mathematics? Emily hesitated, glancing again toward the cleaning cart waiting quietly against the back wall. A few years, she answered. The response triggered a visible reaction among several professors who had spent decades in the field. Harrington looked back at the board one more time before speaking again. Your reasoning suggests far more than casual study. Emily did not respond immediately. Instead, she looked at the equations once more, as if they were simply part of a puzzle she had enjoyed solving. Then she said quietly, numbers make sense to me. The simplicity of the statement settled across the room. In that moment, the audience understood something deeper than the proof itself. The quiet woman who had entered unnoticed had not stepped forward to prove anyone wrong. She had simply followed the logic where it led. And now the entire lecture hall was left staring at the board, realizing that the most brilliant mind in the room had been standing silently beside a cleaning cart the entire time. The lecture hall remained quiet long after the last equation had been written. The proof across the chalkboard still held everyone's attention, but something deeper had settled into the room. It was the realization that the assumptions people had carried into the lecture were no longer standing. Emily Carter stood calmly near the edge of the stage, her hands resting lightly together while the attention of the entire audience remained fixed on her. The cleaning cart near the back wall looked strangely out of place now, as if it belonged to a completely different story than the one unfolding in front of the board. Professor Richard Harrington slowly walked across the stage again, his eyes moving between the proof and the quiet woman who had written it. For a moment he said nothing, as though he was carefully choosing words that carried the honesty the moment required. Finally, he turned toward the audience. In mathematics, he said thoughtfully, the truth of an idea does not depend on who presents it. His voice carried clearly through the hall. It depends only on whether the logic holds. Several professors nodded in agreement. Harrington then turned to Emily directly. The tone in his voice had changed completely from the amused challenge he had delivered earlier. Miss Carter, he said with calm respect, your reasoning today has strengthened this proof in a way I had not considered. The room remained silent as he continued. That deserves recognition. Emily looked slightly uncomfortable with the attention, but she nodded politely. Thank you, she said quietly. Dr. Michael Bennett stepped closer to the stage with visible enthusiasm. I believe many of us here would be interested in seeing that reconstruction explored further, he added. With your permission, of course. Emily glanced at the board one more time. The chalk lines were beginning to fade slightly as dust settled along the tray below, yet the logic behind them had already settled into the minds of everyone present. I only followed the numbers, she said gently. A few students smiled at the simplicity of the answer. Harrington looked toward the back of the hall, where Emily's cleaning cart waited beside the wall. For a brief moment, he seemed to consider the contrast between what everyone had assumed when she first raised her hand and what had now been revealed. Then he spoke again, this time to the entire room. Let this be a reminder, he said calmly, that brilliance does not always announce itself with titles, offices, or introductions. The statement hung in the quiet air. Emily stepped away from the board and began walking back toward the aisle she had come from earlier. Her footsteps were just as soft as before, but the way the room watched her had completely changed. Students moved slightly in their seats as she passed, some offering small nods of respect. When she reached the back wall, she placed her hands on the handle of the cleaning cart again, as if returning to an ordinary task. Yet nothing about the room felt ordinary anymore. The equations on the board remained as proof of what had just happened. A quiet woman who had entered unnoticed had changed the entire direction of a lecture simply by seeing the truth hidden inside a problem. And as the audience continued staring at the board, one thought became impossible to ignore. Sometimes the sharpest mind in the room is the one nobody thinks to look at.